with some variations in your lecture notes. But anyway, it starts on page 26. Well, actually, 7. Yeah, 8. I cover it with each. I cover it with each organ. But yeah, it should be page 8. And so this is showing a cross-section through the small intestine, which is our template. So when we look at the stomach, or we look at the mouth, or we look at different components of the digestive tract, we're going to see these different regions. So we have a model that looks similar to this from the small intestine. We're not going to learn all of its components today because it's small intestine, but you can see the 4 layers of the wall of the digestive tract. And these 4 layers are the mucosa. So from here to here is the mucosa. From here to the surface epithelium is mucosa. Then we have the submucosa, which is this layer here. The muscularis externa, which is this layer here. And finally the serosa, which is exactly the same as our visceral peritoneum. All right. So this is, we'll look at it as part of the small intestine, but we can also see the basic plan of the alimentary tract here. So may I erase the board? Muscularis mucosa belongs to the mucosa.
Oh, belongs to the mucosa?
Yeah, it's the deepest part of the mucosa. But, so in 430, you learned about 4 different types of membranes. Skin was called cutaneous membrane. Our peritoneum and pleura and pericardium are serous membranes. We have a mucosal membrane, which is what we're going to be talking about here. And then synovial membranes were the 4th type. All of them except synovial membranes had 2 classes of tissues. Do you remember what those were? They were described, they also had muscle and nerve, but they were described as an epithelium plus connective tissue. Okay, obviously you're going to have innervation as well. So when we talk about our peritoneum as a serous membrane, what would the epithelium be? Simple squamous. And our connective tissue is always loose, irregular connective tissue. Okay? So with skin, our epithelium is cornified, stratified, squamous. And the epithelium is still loose, irregular connective tissue. And then we add the reticular layer of the dermis. So I can erase this now? All right, so when we look at the respiratory tract, that was a mucous membrane. All right, and we had a great variety of epithelia. So in the nasal cavity, we had pseudostratified columnar. In the oral and laryngeal pharynxes, we had non-cornified, stratified squamous. Then we picked up pseudostratified columnar and went through simple columnar, simple cuboidal, and finally simple squamous. The digestive tract, we only have 2. Okay? So we start out, our mucosa has an epithelial component. And at the beginning and the end, this epithelial component is to resist abrasion, and it's non-cornified, stratified squamous. Thank you. We find this in the mouth. The esophagus. And the anal canal. Yeah, that's the mouth. So pharynx, mouth, pharynx, esophagus, anal canal. In between, the other epithelial type is simple columnar. Will it have cilia or microvilli?
Microvilli.
Microvilli. to increase surface area for secretion and absorption. So microvilli, and most of it will have goblet cells secreting mucus. Now in the respiratory tract, the goblet cell, the mucus, was to trap dust particles. The purpose in the digestive tract, well, it depends on where we are.
Peristalsis.
No, if we're in we don't really have goblet cells in the stomach, but we do have mucus cells. So in the stomach and the small intestine, the mucus is to protect. We have a single layer, and we have harsh digestive enzymes, and we don't want to be digesting away our walls. Yes?
Stomach and where?
Small intestine. When we get to the large intestine, it's for lubrication. All right, because we're reabsorbing water, and the fecal matter gets dry, and so this creates a slippery surface as it moves through the large intestine. Our connective tissue is loose, irregular. Okay. Now, the same term that I'm going to write on the board is used in the respiratory system. We just didn't use it. But this is also known as lamina propria. All right, so this connective tissue right here would be the lamina propria. Okay. Actually, wrong place. It would be the yellow tissue. Yeah, this is the fold of our muscularis mucosa, so it would be this yellow tissue. On our model, the lamina propria would be above our muscularis mucosa, would be all this gray material in here, would be the loose irregular connective tissue. Finally, in our template, the deepest part of the mucosa is 2 layers of smooth muscle that help to throw the mucosa into fold, and that is known as the muscularis mucosa.
Not the muscular externa.
Not the muscularis externa. That's also smooth muscle, but it's a deeper layer and much thicker. That's the 2 layers. So all of that is the mucosa. Okay, if we go back to this, actually let's go forward. So in this slide, a cross section through the tube, all of this yellow would be the mucosa, and this pink line right here would be the muscularis mucosa. So that would be the deepest part of the mucosa. The next layer of our template is submucosa. Okay, that would be the purple layer here. That's connective tissue. And it's a dense, irregular connective tissue. At a couple of places we modify, it's going to have small arteries and arterioles and lymphatics and nerves and so on. In a couple of places we modify it with the addition of mucus-secreting submucosal glands. These are not goblet cells, but are submucosal glands. Again, extra mucus for protection, and we find it on either end of the stomach. Organs that are attached to the stomach. So at the distal end of the esophagus to protect from splashing up of hydrochloric acid. And at the proximal duodenum, where we have the acidic chyme, what we call the churned food from the stomach, leaving. and going into the small intestine. It hasn't yet been neutralized because we haven't added the bicarbs from the pancreas. So, proximal duodenum. Now, I could write to the bottom of the board, but the students in the back would have difficulty, so let me know when I can erase what I have written there, and we'll do the last 2 layers.
You can erase mucosa.
What's the function for the proximal duodenum?
Well, the function, the reason
No,
we
I mean-
have this